Rational expressions. A quotient of two algebraic expressions is called a fractional expression. Here are some examples. 2 divided by x minus 1, y minus 2 divided by y squared plus 4, y cubed minus x divided by x squared minus 5x plus 6, and x divided by the square root of x squared plus 1. A rational expression is a fractional expression in which both the numerator and the denominator are polynomials. Notice in our examples here, there are variables in both the numerator and denominator. Technically, there doesn't have to be a variable in the numerator. We could have a constant, because a constant is a polynomial. It's just a polynomial of degree 0. So, for example, the first three expressions in the above list are rational expressions, but the fourth is not, since its denominator contains a radical. In this section, we'll learn how to perform algebraic operations on rational expressions. But first, let's look at domain. In general, an algebraic expression may not be defined for all values of the variable. The domain of an algebraic expression is a set of real numbers that the variable is permitted to have. So some equations have a domain of all real numbers. For instance, that would include polynomial equations, and linear and quadratic are a type of polynomial. Exponential, trig functions, certain trig functions, but only sine and cosine. Am I missing anything? If I think of it, I will put it up there. Some functions have restricted domains. Alright, so logarithmic equations always have restricted domains. Oh, I did think of another one for all real numbers. Radical with odd indexes, odd roots. Cube root, fifth root, seventh root. Restricted domains, logarithmic, the radical with even roots. Square root, fourth root, because we can't take a square root or a fourth root or sixth root of a negative number and have that be a real number. And all of the other trig functions. Except sine and cosine. Boy, I took more space than I thought. I'm going to have to move that up. Come on. Okay. So these always have restricted domains. There's one other that may have a restricted domain, and that's rational functions. I don't know, I lost my S. Well, it'll be rational function, where the denominator equals 0. Right? So we have our non-restricted, right? You can plug any number you want in there. And then restricted domains, logarithmic, radical with even roots, all trig functions except sine, and keep losing my S's. Really need that S. And then rational functions where the domain is 0. So we have two examples here, two rational functions. Now we just need to figure out where the domain would be equal to 0. Oh, let's do A. So that one's an easy one. That's quadratic, a type of polynomial. The domain is all real numbers. That thing that looks like a fish or an S is supposed to be an infinity sign. I have a tendency not to make them very pretty. Coupled with the board, that looks better though. All right, now let's look at the next two. Those are rational expressions, and we need to figure out where the denominators would equal 0. Now the second one we can factor. All right, so we have x squared minus 5x plus 6. 1 times 6 is 6. So we need two numbers that negative 6, multiplies to give us positive 6 and adds to give us negative 5. And that would be negative 2 and negative 3. So we can use factor by grouping. X squared minus 2x plus negative 3x plus 6. First to our group, second to our group. We can factor an x out of x squared minus 2x. X squared divided by x is x. 2x divided by x would be 2. So we have x minus 2. And we can factor out a negative 3. Negative 3x divided by negative 3 is an x. 6 divided by negative 3 is a 2. Factor out that repeating x minus 2, and we are left with x minus 3. So that means here that x cannot equal 2 and x cannot equal 3 in this particular example, because that would make the the denominator of the fraction equal to 0. So we can write the domain as all real numbers, but just skip over those values we can't use. So the domain would be negative infinity to 2, because that's the smaller of those two numbers. That symbol there means union, right? It's another way to say and. So negative infinity to 2 and 2 to 3. So we're just skipping over 2, and we're skipping over 3, and everything else is okay. Right? So everything between negative infinity to 2 and 2 to 3 and 3 to infinity is fine. Just 2 and 3 aren't fine. The last one's pretty easy to figure out. Right? If the value that would make the denominator equal to 0 is 5. So our domain is everything but 5. We're skipping over 5. There we go. That's all there is to that. All right. Let's look at some operations with rational expressions. All right, so simplifying rational expressions. To simplify rational expressions, we factor the numerator denominator and use the following property of fractions. So in other words, if you have the same factor in the numerator and the denominator, you can cancel that factor out. This allows us to cancel common factors from the numerator and denominator. All right, so we're going to factor our two expressions here, that are the polynomial in the numerator, polynomial in the denominator. The numerator is super easy to factor. It's a difference of squares. So this is going to be square root. So the square root of x squared is x, minus square root of 1 is 1. And then square root plus square root. I mean, that's a pretty easy factor. X squared plus x minus 2 is a pretty easy factor as well, right? Because our a is 1. It's pretty easy to figure out the two values are going to be positive 2 and negative 1. Right? So x plus 2, x minus 1. So when a is 1, the factoring on a quadratic is pretty easy. And you can see if we multiplied that back together again, we would have x times x would give us x squared, 2 times x would be 2x, minus 1x, so that would be x, and then 2 times negative 1 is negative 2. We can cancel out these x minus 1, right, because it appears in both the numerator and denominator, and that gives us the simplified form x plus 1 divided by x plus 2. And that's all there is to reducing rational expressions by cancellation. Let's look at multiplying rational expressions. Now, I'm going to give you a hint, and the hint is it's a good idea to check to make sure you can't cancel anything first before you multiply, to make your multiplying a little bit smaller. It's a lot harder to multiply, get something larger, then try to factor it all and cancel, and maybe you could have canceled in the beginning. Okay? Now, if we factor and we can't cancel anything, all right, well, then we're done. Right? We just multiply. We can just use the original expression and multiply. All right, so x squared plus 2x minus 3. All right, so multiplies to give us negative 3, adds to give us positive 2. That's going to be 3 and negative 1. Right? So this would factor to x plus 3, x minus 1. It's pretty easy to figure out the factors when a is 1, right? Because now we're just looking for the two values that's going to multiply to give us c and add to give us b. All right, and then let's factor x squared plus 8x plus 16. Well, that is a sum of squares, right? We have that pattern there, a squared plus 2ab plus b squared, right? Because the 8 there would be 2 times 4 times x, and the square root of 16. B is you can see that a here is x, and b here is 4, right? And 2 times 4 times x would give you 8x. So this is just going to factor to x plus 4 times x plus 4. Here, I'll move this down. All right, now let's factor the other expression. All right, so we can plot a greatest common factor, 3 times x plus 4, right? So we can factor out a 3 from 3x plus 12. Just divide both of those terms by 3. And x minus 1 is as simple as it gets. Now when we look at this, we see we could cancel. So it's going to be a lot easier if we just factor these simpler expressions and then reduce, rather than multiply and get this really large expression. Then we're trying to factor something much more complicated. It wasn't that difficult to factor these expressions. And if we didn't simplify, we could go right back to the original equation if we liked. All right, so we can cancel out the x plus 4s, and we can cancel out the x minus 1. Now we've got something pretty easy to take care of, right? So we've got 3 times x plus 3 divided by x plus 4. Well, that's pretty easy. 3x plus 9 over x plus 4. So always check to make sure you can't reduce first before you multiply. It's just easier. Now, dividing rational expressions is an awful lot like multiplying, except you're going to multiply by the reciprocal. Right? So to divide rational expressions, we use the following properties of fractions. Right? So if we're dividing one fraction by another, it's the same as multiplying that first fraction by the reciprocal of the second fraction. So this says to divide a fraction by another fraction, we invert the divisor and multiply. So for instance, if you were going to divide, let's do something simple, 5/3, and you were going to divide that by 1/3, you would actually take 5/3 and multiply by the reciprocal, and that would just be 5. And that makes total sense, right? Because of course there's going to be 5/3 in 5/3. All right, so, and you don't have to put that in your notes. All right, but let's do the one that is in your notes, the one below here. So we want to perform the indicated division and simplify. Again, it makes sense to factor, and then let's invert first, and then we'll factor. We'll reduce, and then we'll multiply, because we don't want to accidentally reduce before we invert. So let's just do that first. So we have x minus 4 divided by x squared minus 4, and then that's going to be times the reciprocal. So x squared plus 5x plus 6 goes in the numerator. X squared minus 3x minus 4 goes in the denominator. All right, so you can't really do anything with x minus 4. I mean, you really can't. X squared minus 4, difference of squares, that will be square root minus square root times square root plus square root. X squared plus 5x plus 6, that's an awful lot like the one we found the domain for, except instead of 5 being negative, 5 is positive. So this is going to factor, multiplies to give us 6, adds to give us 5. That's going to be x plus 2 and x plus 3. And then multiplies to give us negative 4, adds to give us negative 3. That's going to be x minus 4 times x plus 1. So now we inverted it. right? So we're multiplying by the reciprocal. We factored and reduced, because we're going to reduce right now. So we can cancel the x plus 2's, the x minus 4's, and that's it. So now we have x plus 3 in the numerator and x minus 2 times x plus 1 in the denominator. Since there's just, it's a 2 by 2, one binomial times another, we can just mentally use FOIL and not have any problem here. So that would be x plus 3, of course, in the numerator, and then x times x is x squared. Outer term is x, inner term is negative 2x, so x plus negative 2x is going to be a negative x, and then negative 2 times 1 is negative 2. So here we just multiplied. Right? And that's all there is to that. Right? Not too bad, right? So multiplying and dividing rational expressions, not too complicated. And I'm going to take a break here, and in the next video we can look at adding and subtracting rational expressions. Okay, thanks for watching.